Hello everyone, welcome you to yet another lecture of simulation of business systems and applied approach, and I am Dr. Suman Samanto. So far we have discussed two cases on which we have shown you how a decision node can be used to develop a arena model, and we also have seen that how different create nodes can be used on a single simulation model, and that can be utilized to run a simulation model, and how we can analyze the simulation model, and we find out that where we need to put in a resource, and how to improve the model and how to improve the process. Now we will go to the third case in which we will discuss about the use of assigned node. So to discuss this using of assigned node, first of all what we will assume here is that the bank have common windows for all the three operations that we have discussed previously, which can serve a customer for their deposition or withdrawal, can also do making the demand draft, and can also do other things as well. So the customer, depending upon the customer's variety, the customer do not require to choose different window. They need to go to a same window, and then they need to find out, they need to serve their work. So we'll first try to develop this thing and in the pen, and then we'll go to the arena, and we'll tell you why and how this assigned node can be used and required. So first of all, say we'll start with previous case. We use three different create nodes. C1 is for the customer that require money deposition, money deposit or withdraw. C2 is for the customer who require a demand draft. And C3 are the customer who require other services. So we'll start with the previous convention as well, and we have said that we have only same window can serve all the three operations. So we have one process where process window where all these three customer can reach and get it served. So this is basically called as window, and the process it can serve is all the three. But the problem is that, as we have said in the previous cases as well, the demand draft making requires two processes. It is one is done at the window, and the second is the draft requires to go to the manager for a signature. So the problem is that if we go in that way, in the way like this, and we add a process here, signature, then the problem that will occur is that all these customers that reach to the window will go to the signature process as well. But we specifically do not require this thing. What we require is that only the customers that came for making their demand draft, they need to go to the manager and get their signature on the get his signature on their draft. So to do this thing, what we need is that we need to identify the customer separately. So how we will do that? We will use assign node, and we will assign some value to each customer, so that that value will identify that customer and direct them towards the signature node. How we will do that? We will put one assign node in front of each customer. These are assigned node 1, assigned node 2 and assigned node 3, and we will put some attribute value. This attribute value will significantly identify the customer, and drive them to the next process. Next process means, because the window process is same and the next process is signature, and for the signature we need only the draft making customers to go. So we will put an attribute to all these customers. So before this signature we will put another decision node, draft or not. If the customer wants to make draft, then they will go to make the signature done and exit. And if the customer is of the other two types, then they will go directly to the exit. Understand this thing? So now since we have drawn this thing, this process flow on the pen and paper, now we will go to the Arena again and we will try to develop this in the Arena simulation software. So very like to the similar case, we will start with adding 3 create nodes, which will create specifically separate kind of customers. So first customer is first kind of create node will develop the customer whose kind is basically withdraw of money or deposit of money. Notification we will put that in every say for example 3 minutes one of such customer arrives at the bank. To the second case as well, we will make this name as customer underscore draft. This one should be put as minute, and the value maybe say for example every 4 minutes one customer comes to make a draft. Similarly, for the third case, which can be renamed as customer other, which is again randomly distributed, randomly exponentially distributed, and the value will be say for example per 6 minutes one customer comes for availing these other services. So as we have said previously, here we have only one window, one kind of window. Maybe there may be more than one window, but all the windows can serve all the 3 kinds of such customers. So we will put the process name as all because it can serve all the processes. We will use usually release again. We will put the resource name as window. Say for example, for this particular case what we assume is that all the customers are getting served with similar mean and standard deviation using a normal distribution. Say for example, all the customers are got served by with a mean of say for example 6 minutes and with a standard deviation of 1 minute, irrespective of the what customers want to get their service. As I told earlier, you need to put assigned nodes in between to specifically identify these 3 customers, so that for the customers who want demand draft, we can direct them to the manager, and all the other customers who don't want demand draft, they can directly exit after they have completed their work at the window. So here is the assigned node. So we'll put assigned node in front of every customer. So as I said you earlier that we will put the attribute value as say for example customer 1, for the customer 1, for the customer 2, customer kind of 2 who want to make demand draft, we will change the, we will add an attribute value, we will say attribute name as customer and value as attribute name as customer 1, we will put the attribute as a customer 1 and the value is 1. Similarly, for the second case, we will name the attribute as attribute 2, attribute as customer 2 and the value is 1. Similarly, for the third case as well, we will put the attribute name as customer 3 and put the value as 1. So, we will connect them again with the process, make the connections by using the connectors. Then we will have to put a decide node to decide whether the customer belongs to the draft making group or the customer belongs to the other two groups. So, similar to in the previous case, we have used n way by chance in the first example, because we are basically dealing with the percentage of customers that are going to get served in various processes. But here the case is that we want to identify which customer is that, which customer is of a particular type. So, we will use this two way by condition. So, the what is the condition? Condition is that the attribute that we have already defined in the assigned node. So, what attribute we are actually looking for? We are looking for customer 2, because customers 2 are dealing with the draft making. So, what is the condition now? Whenever this thing passes through this decide node, the decide node will check whether the customer 2 value is equals to 1 or not. If the customer 2 value is equals to 1, then they will direct it towards the manager, and if not 1, then we will direct it towards the exit. So, that is what this decide node will decide. So, similar to after the decide node, we need to add the process of signature, which will be done by the manager. We will add delay release here, normal distribution, minute. Previous, like the previous case, we will put 10 minutes as a mean and 2 minutes as standard deviation. Okay, this will be the manager. So, we will add these two nodes, and finally we will put the so we can put a separate dispose node for the other cases as well. We can make the node dispose node same as well. I mean, that does not have any difference in the output if we make this as a separate, only to make the model more clearer that others are going away and making these arrows more clearly visible. I am just making this disposal node as different, but it can be made same disposal node as well. I mean, this is just an exit node. Remember, for this process, what we are assuming is that all I mean, remember what in this model what we are assuming is that all the 3 processes that a customer seeks will have a same time spent in the similar kind of time spent in the window, and all are having similar normal distribution, standard deviation that will be within which the customer will be served. So, now we will run this. Okay, one more thing is that previously we have used 3 separate windows, and we have used only one window. So, let us increase the window number initially. So, say that there is not only one window, there is 3 windows, and all the windows are capable of serving all the 3 tasks. So, now we will run this simulation model and we will check how the system is working. As I said earlier, we need to find out the run setup again and again each time we run the process, otherwise it can go up to the infinite length and we cannot get a result within finite times. So, similar to previous case, we will also we will again add this application length as 40 hours and hours per day as 8 hours. Now, we all set to run this simulation model, and we can see it is running. And is it running? No. Okay. As you see, it's running very quickly, so we need to put it a little bit faster so that we can get the results earlier. The results have come, so let's check the result. So as you can see, the total number of people get served is 6138. Here again, there is a huge discrepancy in number of people who came to the bank and number of people who got out from the bank. So definitely there has some issue with the system, and there may have requirement of some entity, some other resources that will be again understood by analyzing the queue and resource tab. So when you see the queue tab, you can see that all, I mean the windows, 3 windows that we have introduced, they have an average queue length of 41.36 with a maximum queue length value as 80.416. Similarly, for the signature queue also there has an average queue length of 49 and maximum value of 99. So definitely there are people who are waiting in the queue to get served, but they got not served, they didn't get served throughout the day, I mean throughout the period tenure within which we have run the simulation. So number of people waiting in the queue, that we can see that for the in the all queue there has around 1800 people are waiting with a maximum value of 3500 people are waiting. So definitely there need to add some more number of windows to get served in the bank. It seems that the bank is very busy, but we have only 3 windows to get them served, and they are not getting served with this 3 windows. Similarly, for the signature queue as well, we see that there has only 500 number, there is around 500 numbers of on an average waiting in the queue, and with the maximum value of 1000. When you see the resource utilization, you can say that again the window is fully utilized with around 1 utilization factor, and manager also having utilization factor near about 1. So to do that, it is very much significant that we have to add more windows in the system to get the people served. So when you see this diagram, I mean this after run GUI of this window, you can see that there are number of customers waiting in the queue in the all window, and similarly there are number of people who are waiting in the queue in the signature window after the end of the run. And similarly there are 3581 numbers, though the numbers are very hazy and not visible very well, but it says that there are around 3581 number of people who haven't got served within the run period in the all queue. And similarly for the signature window, there is around 1853 number of people, 1853 number of people who have not got served after the tenure of this run. So definitely we need to add some resources here in this all window and in the signature process as well. So what we will do is that in the previous similar to the previous case, we will add we will go to the resource tab. We will increase the capacity from 3 to say 4 in the window, and we will increase the capacity of manager as converted to 2 from 1. Now after this change, what we will do is I will run it again, and we will check how much it has been, the process has been improved with the addition of these 2 new. Okay. So you can see that the number of output that has been increased from the previous case. When you go to the entity tab column tab, then you can see that there are a number of inputs, I mean a number of people that has been entered into the bank throughout the tenure of the simulation is 10,639, whereas number got served is 9,256. Clearly there has still some discrepancy in this number. And again we can see that how the queues are behaving. We can found that by analyzing this queue and resource. So again you can, when you see this queue tab, you can see that all queue still have an average waiting people still has a length of 13, the all queue still have a number of average as 13. Similarly, with the maximum value of 22, waiting time, this is basically the all queue has a waiting time of 13 minutes on an average with a maximum value of 22.87 minutes. Similarly, signature queue has an average waiting time of around 11 minutes and with a maximum value of 23 minutes. Similarly, number of people that are waiting in the queue also can be analyzed as that in the all queue there is around 573 people are waiting on an average with a maximum value of 1060. Similarly, for the signature queue as well, there has a number of 146 0.70 people waiting on an average with a maximum value of 327. So, it signifies that when you see the resource, then also you can see that the manager and the window also have almost weird out with their work. They almost have one utilization factor. That means they do not get any time during their 8-hour shift, and they are all busy during all the times. So definitely there has a requirement of adding another resource in both the cases, in both the processes. So we will do that again and we will run it again. Say in the window we will add one more resource, and say in the manager case tab we will again add one more resource. So now we will run it again and then we will see how the system performs. So it has been done. So now we can see that the number out has again been increased. Again the number of input is around 10,713 and the number of output is around 10,705. That is pretty very much close, and I think now the system has been performing pretty much well. Now when we see the queue, then we can see that waiting time in the queue has been reduced significantly. Significantly by means of that only the all queue has around 0.06 minutes waiting time with a maximum value of 0.5 minutes waiting time. Similarly, signature queue have only 0.13 minutes of waiting time with a maximum value of 1 minute of waiting time. That is that we can see that we have improved the process very significantly. While we see the all queue, number of waiting in the queue, we can see that the all queue have around 3 people are waiting on an average with a maximum number waiting as a 28. And similarly for the signature queue, there is 2 number of people waiting on an average, and there are 19 number of people with a number of people are waiting at max. So when you see that the utilization factor, then you can see if we can find that the utilization has been predominantly reduced from 0.99 to 0.8489. That is pretty much acceptable. There is pretty much acceptable resource utilization, because if it is going above 9.95, this may lead into the conclusion that the process requires another window to for the customers to be served. Otherwise, there will be there will be a number of unsatisfied customers who didn't get served after the completion of the time. So the issue is that here the thing is that to be noted that when we start analyzing the arena simulation model, we put resources one after one, and then we try to find out how the model is behaving. We do not irrelevantly add more resources so that at the end of the time we find that the system is performing well, but that is not basically the aim. We need to add one resource after another, and then we need to check it by running it more than one time, and then we will need to find out that how the resource works. As you can see in this window that a few more things that to be added in this is that you can see in this window that there are 2 customers which are not got served in the all node, whereas there is no customer who has been got served in the signature node. Not true. It says 7 customers. It is called 0 customer that has been got not served in the signature window. Now, if you closely see these values, I am not showing sure that whether it is visible to you guys or not. I am just trying to increase it so that it can get a little bit of visibility. See, for example, this customer other, you can see that there are 2418 customers has been produced under the tab line as customer others, customer draft, there is 3653 number of customers has been created in this by this creation node. There are around 4642 number of customers that has been created by this customer withdraw depositional node. So you can check these things here as well. I mean for a small instance as well. Similarly, you can see at the decision node as well. The decision node as well, there are 3651 entities that have been diverted by this decision node. For the 3651 cases, the attribute became, I mean the attribute basically became yes, became truth. So they went to this signature, and for the other 7055 number of people, the attribute of the attribute customer 1 customer 2 equals to 1 not became false, so they directly got exit. So in this way you can check a cross check here as well, that whether the number of people who has been entered into the process and whether these two things are matching or not. This also you can put a check in the simulation arena simulation. So that's all for the second part of this lecture, and we will go to the third part in the next lecture.